Welcome to the structure analysis course. So in the after last lecture, we have discussed how to draw the bending moment and shear force diagram, how to develop the bending moment and shear force diagram for simply supported beams or maybe in a frame structure. So in this module, we will start discussing about analysis of cable. So in the real day-to-day life structures, you will find in the many places where we use cables. So one good example will be cable stayed bridges. You can see many bridges in India are actually cable stayed or suspension bridge. Here all the loads are taken by the cables. So similarly, so basically cable in the beginning lecture we have discussed, cable is a tension member, means it can take only tension force. So cable are often used in engineering structures for support and transmission of loads from one member to another. So when used to support suspension roofs, bridges, or maybe in a trolley wheels, cables from the main load carrying element in a structure. For example, if you see right side, it is a cable stayed bridge. Here, the entire load in the deck will be transferred through this cable to the main column, main pier, and ultimately load transfers to the soil. So today we'll discuss how to analyze the cable stayed structures. So there are two types of loads acting on a cable. So one is point load or concentrated load, and another one is distributed load. So in this lecture today we'll discuss about how to analyze the load which is under the concentrated load is acting on a cable. And in the next lecture we'll discuss the uniform load if it is acting on a cable, how to analyze and how to determine the forces in a member. So for our analysis, before starting analysis, let's assume few parameters. First assumption would be this cable, whatever we will use in a structure, that is inextensible. For example, like this cable you can see. So after application of load, if we apply P1, P2, these concentrated loads, the length of the cable won't change. Earlier, whatever is the length, maybe L1. So after application of load also, the cable is, length is same, L1. So this is our first assumption. Next assumption is the weight of the cable will consider it as a negligible. So even though it will have very small amount, but for our simplicity in analysis, we will consider it as a zero weight. And the shape of the cable before loading, it may be straight, like A to B we are just tying a cable. If you imagine A to B, we're just tying a cable, and after application of the load P1 and P2 in the 2 points, maybe you are hanging something, so the shape of the cable now changed. So this, after application of the load, the shape is now constant. So this is our stable structure. So after application of the load, this whatever, maybe it will create some angle with the support, and maybe there will be some sag in the some portion of the structure. So this is the overall cable structure where two concentrated loads are acting, P1 and P2. So here total how many unknowns are there? If you see, this is this, you can imagine two support. This is one support, and one cable was connected A to B. Now after that you apply two load. Maybe you have hanged something, some loads, two loads. One is P1, another is P2. And after application of the load, this is a buckle shape of a cable. So the cable's length is constant. There is no change in the length. That is our assumption. First assumption, and second assumption is the weight of the cable is negligible. So now total how many unknowns are there? So we have applied two external force, P1 and P2. So this cable is resting on these two supports. Both supports are hinge support. So as we have discussed in our earlier lectures, supports are basically hinge support has basically two types of reactions. So one will be horizontal reaction, another will be vertical reaction. Similarly, for this side also you have two unknown reaction. One is horizontal reaction, another is a vertical reaction. So from support you will get four unknown. So two in each support. Now what are the next unknown? So next unknown will be there may be some force, tension force in this cable. So this portion of the cable will have some force. Maybe for this is T1 for example. So this is also unknown. So this also will add plus 1. Now with this cable C to D, in this section also you will have some tension. So this that tension we'll call it T2. So that is also unknown. So plus 1. So again in the D2B, in this section also some cable force will be there. So that cable force may be T3. So plus 1. So total you get total 7 unknowns, right? And then two more extra unknowns. So before application of this P1 and P2, the shape of the cable was something this straight line, right? A to B, the shape of the cable was like that. But after application of load P1 and P2, the shape of the cable now changed. So now there is a sag. YC is also unknown and YD is also unknown. So these two are also unknown. So total 7 plus 2, 9. So in this problem, you have total 9 unknowns. So 4 support reaction, 3 as the forces in the that each cable segment, and 2 is a and 2 for 2 unknown is the sag in the cable. So total 9 unknowns are there. So we have to calculate all the 9 values to design. So why we need to calculate all the values here? Because our main objective is to design the entire structure. So if you imagine you are designing a structure, so here you have to design two supports, support A and support B, and then also the length of the cable, not length, basically the material. So if we are using a steel cable, then we have to identify what should be the diameter of the steel cable. So these are the design parameters we have to tell. So before finding out all the parameters, like what should be the diameter of the cable, we have to find it out how much load is coming into the cable after application of the load P1 and P2. So that's why our structural analysis is very much important before we do the design of structure. So in the structural analysis, basically we are finding out all the unknown forces in each member and also the sag. So let's solve a quick problem and then the actual concept will be clear. So this is the same problem whatever we discussed in the last slide. So the same two supports are there, A and D support, and that cable is connected through A to D, and two concentrated force are suspended. So B is suspended, C is suspended, and the distance also given, how much meter it is. So after application of the load, this structure is now stable structure and the shape is now constant. If we don't increase the load 3 kN, 8 kN, if it is fixed, then the shape of the structure is now constant. And and two concentrated force B and C are acting, and all the distance also we have computed. So 2 meter, 2 meter, 1.5. This height is 2 meter, and the distance between these two support also you have the 2 meter is given to us. So we have to we have to do the structural analysis of this tension structure, tension cable. So here total how many unknowns are there? Let's first list the number of unknowns. So this is a hinge support. So you have two unknown, vertical and horizontal. So here two, here also we have two unknowns. So 2 to 4, and then you have the member force here at A to B section T1, B to C T2 member force, and C to D you have another member force, that is T3. And this length is given to us, so that is known this time, but here one unknown is given, that is A to B. This H is also given, it is unknown. So total how many forces are there? Total how many unknowns? So here two unknowns, this support also we have two unknowns, and then this distance height is also unknown H. So 2 2 plus 1 3 5, and then 3 cable tension. So total 8 unknowns are there. So to solve this we need to have total 8 equilibrium of equations, then only we can actually find it out all the member forces. Now how to compute all the 8 unknowns, or how to write the 8 independent equilibrium equations from the structure. So now we'll apply, if you imagine, if you recall, we discussed truss analysis. So in a truss member also has similar properties, whatever here we discuss cables. So but the only difference between truss and the cable is truss member basically is a it can take tension as well as compression both, whereas in a cable structure can take only tension, so it can't take any compression force. but the analysis will be somewhat similar to the truss. So each joint in a cable structure will have two equilibrium of equations. So summation of all the vertical forces equal to 0 and summation of all the horizontal forces equal to 0. So these two we have the equilibrium of equation for each joint. So total how many joints are there in this structure? Number 1 joint, 2 joint, third joint and fourth joint, right? So here we have total 8 joints, 4 joints, and each joint will have two equilibrium of equation. So total 8 equilibrium of equation we can write from this structure, from this tension structure, and we have the 8 unknowns. So easily we can compute all the values. So first, our first job will be to draw the free body diagram of this entire truss. So by inspection, we know already we discussed there are 4 unknowns: ax, ay, dx, and dy, and 3 cable tension force T1, T2, T3 as we discussed. So total we have 8 unknowns and we have 8 equilibrium equation also. So from this we have to compute all the unknown forces. So this diagram is a free body diagram of this one. So what we did is we took a section at this point. So here we took taken a cut and we drawn the free body diagram. So whenever we take any section, if you remember earlier lectures we discussed, whenever we take any section, basically we are exposing the internal forces. So whenever if we take a section here in this point, then how many internal forces will expose? So here only cable, basically we are making a section. So in cable, each cable you will have a one tension force only, the T3 for example here. So this T3 basically we are exposing. So so whenever we take a section here, so TCD is a internal force we are exposing here. And this is a free body diagram, and AX, AY is a two unknown. Similarly, TCD is a unknown for the cable. So now let's calculate the AX, AY, all the unknown forces. So this is the same free body diagram whichever I shown in the last slide. So our first job will be find it out the value TCD. So as we have taken a section here, so we have exposed TCD. So let's first compute TCD value quickly. So how to do that? So if you recall, this A is a hinge joint, right? Hinge joint has two reactions, AX and AY. But what about the moments at A? So as we know already that moment in a hinge joint is 0. So that's what we have used. So this equation we have used. Summation of all moments about A should be equal to 0 because A is a hinge joint. So hinge joint don't carry any moment. So if we apply this equation and write down all the moments which are passing about A from this free body diagram, let's see what we get. So TCD, basically TCD we have exposed here. So it is we have taken a cut and we expose TCD. So whenever we have taken a section here, so TCD is basically the inclined force, right? Inclined force. So it will have two components. One is vertical component, and another is horizontal component. So and this angle also given to us. So height is given 2 meter and this total length also given 1.5. So we can easily compute what is the slope. So 3 4 5. So this is the slope. Base is 3, height is 4, and this inclined is 5. So we can easily compute what is the angle of this line, angle of this TCD. So let's compute quickly. It has two components. One is horizontal component, one another is vertical component. So both the component will produce moment about A. So how much will produce this component? So this component, vertical component, TCD's vertical component will produce which anti-clockwise moment. So anti-clockwise moment we have considered it as a positive. So TCD is acting, and what will be this distance, entire distance. So entire distance is already given 2 plus 2 plus 1.5. So total 5.5. So that's what is given here. TCD, and the slope of this line is given 4 by 5, will be basically sine theta. So this is sine component of TCD, and total distance is 5.5. So this entire value is the moment generated because of the vertical component of TCD. So this is the moment which is anti-clockwise, that's why the sign is positive. Now how much moment will produce this vertical component of TCD? So vertical component of TCD will produce TCD into cos of this angle. So cos will be 3 by 5, right? TCD into 3 by 5 into what is the distance total? From this point to this A distance is 2 meter given to us. That's why multiplied by 2. So this is also a anti-clockwise moment. So anti-clockwise means positive we considered. So these two are the moments coming from TCD. Similarly, you have 3 kilonewton force is acting downward. So this 3 kilonewton also will produce anti-clockwise, sorry, clockwise moment. So clockwise means you have the negative. Our anti-clockwise is positive we considered. So clockwise is negative moment. So how much it will be? 3 into distance is 2. 3 into 2. So that's what is written here. 3 into 2 moment it will produce. Now what about this 8 kilonewton also will produce clockwise moment, and how much will be the distance? 2 plus 2 4. So 8 into 4 is the total moment. So this should be equal to 0. So these are the total 4 forces acting about A. So AX and AY is acting through A. So distance is 0, right? So that's why the moment won't be produced because of AX and AY. So these are the 4 forces equal to 0. Now if you substitute, only one unknown is there, TCD. So easily you can compute what is the value of TCD. So now we already computed what is the value of TCD. So now next we have to compute other forces, other member forces. So now we'll apply method of joint. One by one joint will just traverse and we'll find it out all the unknown forces. So now let's do it first. So we know TCD. So now let's take the free body diagram of joint C. So this is a free body diagram of joint C. So just now we have computed what is the value of TCD. So TCD is 6.79. So 6.79 is given. Slope also we know. So what are the unknown forces for C? So the unknown forces, anyway 8 kilonewton is given to us, 8 kilonewton acting downward, and TCD also we know. This slope also given to us. So unknown is TBC and this angle. So this theta BC. So whatever angle this line is making, so that angle also unknown to us. We have to find it out. So theta BC is also unknown and TBC is unknown. So here also we have two unknowns, and from this joint we can write two equations. So we can easily compute the two unknown values. So let's do it. So we have applied summation of all horizontal forces about this point. C should be equal to 0. So what are the horizontal forces? So this is an inclined force. It has a horizontal component. So 6.79 into its horizontal component will be 3 by 5. So cos theta. So 3 by 5 minus, you have this TBC is also inclined force. It also will have the horizontal component. So TBC into cos theta BC will be the horizontal component. So TBC into theta BC is equal to horizontal component. So just make sure the sign convention. So this equal to 0. And now you apply another force, another equation, summation of all horizontal for vertical forces equal to 0 about C. So what are the vertical forces? Same 6.79 has a vertical component. 6.79 into sine theta 4 by 5 minus half TBC is acting downward, so that's why it is minus. And TBC is also acting downward, so this is also acting downward. We consider downward, we consider it as a positive. So upward we consider it as a positive. So TBC is vertical component will be TBC into sine theta BC. So now you have two equations and two unknowns. TBC and theta BC are the two unknowns. So we can solve it and we can calculate what is the two unknown, and the value will get theta BC 32.3. Similarly, TBC is also we got. So now we apply this method of joint into joint B. So let's quickly draw the free body diagram of joint B. So here you already just now we computed TBC value is 4.82. So this is joint B. 4.82 is acting this side, and 3 kilonewton external force is acting downwards, and this angle also just now we computed 32.3 this angle. So here, what are the unknowns we have? We have two unknowns, TBA. So TBA is this member force of this cable, and the angle, it's angle theta BA. So same, we'll apply summation of all horizontal forces equal to 0, summation of all vertical forces equal to 0. So both the equations, let's quickly do it. So TBC has a horizontal component. So what will be horizontal? TBA, so TBA into cos BA. So TBA into cos BA will have a horizontal component, and also for this inclined force we have the horizontal component. So 4.89, its horizontal component will be cos 32.3 degree. So from here, this is one equation. Another equation is summation of all vertical forces equal to 0. So simply with plug in, we write down summation of all vertical forces equal to 0. So two equations and two unknowns, theta, TBA and theta BA. So two equations, two unknowns, easily we can compute all the values. So this is TBA and T and theta BA. So now we have computed all the member forces, and now our next job will be to compute what is the height, right? H. So H also is unknown for us. So H also we have to compute. So how do you compute H? H means height from A to B. So we know the angle B to A. So just now we computed B to A is 53.8 degree. So this angle is just now we computed. So let's do it quickly here. So this height actually we have to compute, that is H. So this angle we computed just now, that is 53.8. 53.8 we computed this angle. So we have to find it out what is the H. So this base also we know it is 2 meter. Just simply we substitute these equations and we'll get what is the height. So using this method of joint, basically we have computed all the member forces in a structure. So that's how actually we analyze the cables which are subjected to constant forces, I mean concentrated forces. So first we have taken a section here and we expose the internal force, and then we have taken moment about A, and then we computed TCD. Once we've calculated TCD, we applied method of joint at C and method of joint B, and we computed all the member forces and then the angles as well as so after using the angles, when using the angle, we computed what is the height. So that's how we do the analysis of cable which are subjected to only concentrated force. So in the next lecture, we'll discuss how to analyze a cable using if the uniformly distributed loads are acting. Thank you.